How's it going, everyone? My name's Mark. Thank you for being with me today on Resource Talks. You're about to watch a discussion that is general and impersonal in nature and which will contain neither professional nor financial advice. It will, on the other hand, likely contain forward-looking statements, and I warn you to take what you hear with a bucket full of salt. Please proceed with caution and do more research before taking any decisions. That all said, Don, thank you for investing your time with me today, sir.
My pleasure. Great meeting you.
So would you please start by briefly introducing Desert Mountain Energy and explaining your role in the company and a bit about your background, please?
Okay, well, I'm the president of the company and I sit on the board of directors. In August of 2020, Robert Rolfing, our executive chairman and CEO, and myself basically took over management of the company. At that point in time, it was a grassroots operation with 55 million shares out, all issued under 35 cents Canadian. Once the transition was complete with Rob and myself taking over management, we did replace a few of the board members, and the board right now doesn't have any previous members on it. Rob was the VP of Exploration. This project is all about Rob Rolfing's 25 years of research into this geological setting that we're in. My role is pretty much strictly dealing with capital markets and fundraising. Rob is all about the technical side of it, how to process the helium, the geological models, et cetera, et cetera. And 2021 was really a team building year for us. We only drilled one hole last year, but we built a team around Rob because when we took over management, Rob did all the duties of the VP of Land, VP of Engineering, VP of Geology, everything except the CFO role. And it was, that included sitting on drill rigs and directing the drilling. So with the team now built around him, we've been able to accomplish a lot more this year. To date, the company's drilled a total of 8 holes, 5 wildcats, discovered 4 helium fields. And what's unique about our company is the environment that we're finding high-grade helium in. 95+% of all helium in the world comes out of traditional natural gas fields. And generally, the grade of a commercial helium credit would be 0.3 to 0.7%. But for a company to get there, they've got to dig through all the components in the raw gas. It's not refining. It's literally separating out elements. If you had a bowl of mixed nuts and you're pulling the peanuts and the almonds and everything else out, you go through the process one element at a time. So the simpler the composition of the raw gas coming out of the ground is, combined with the higher grade of helium, the more profitable and the easier it is to process. So in a natural,
sorry to interrupt you. Let's just take a step back here. I mean, most people are familiar with helium, the second lightest element after hydrogen, as the gas that makes party balloons float. So for the sort of unsophisticated listener who just thinks helium party balloons, could you just give us a rundown? What are the sort of substantive uses for helium? What are the demands for it? Why do you want to search for it in the first place?
The largest application user right now is MRI machines, which will allow you to scan soft tissue damage, unlike an X-ray where you're looking for broken bone, for example. Secondary to that, the large data centers are all cooled with helium. Helium's unique. It's completely inert. It won't marry another molecule. So it's used for purging atomic accelerators, combustion chambers in rocket engines like SpaceX. It's used to create an environment that's contaminant-free for manufacturing stuff like fiber optics. It's used as a component in liquid hard drives. It acts like a lubricant in a liquid hard drive and increases memory by 60% and decreases power usage by 40%. So a Tesla's got 17 liquid hard drives on board. The traditional applications are lifting gas, but other than party balloons, you got to realize that there's a lot of high altitude research done with balloons. The U.S. Weather Service uses a lot of weather balloons. They've had to discontinue some of that service because they can't get helium for their balloons. Any research where you're trying to achieve absolute zero temperatures or near absolute zero temperatures, because helium has the lowest boiling point of any element at 450 degrees Fahrenheit, negative 450 degrees Fahrenheit. All the research into conductivity and magnetism is all done with helium used as a coolant, and nothing else works for it. They've tried to use nitrogen, but there's some issues with nitrogen. It tends to degrade some of the materials when it's used. And the boiling point is 100 degrees above where helium's at. So you're not going to get down to near absolute zero temperatures with it.
Right. And as well as being the second lightest element in the universe, it's also the second most abundant element. Yet here on Earth, I understand its supply is not that simple to secure. So could you explain, where do we find helium on Earth? What are the common methods for extracting it?
Well, as I said, it's a component or a credit in natural gas fields, but traditional natural gas fields, not the shales. And in order to get the helium, you got to dig through all the other elements to get to what they call crude helium, which is 90 to 95%. And then the producer will do an offtake with one of the three specialty gas suppliers out there that dominate the helium market. Like 95+% of it's dominated by three companies, simply buying offtakes, doing the purification process and selling it to the end users, whether it's a chip manufacturer, hospital, or whoever it is. Now, in our case, it's kind of unique. We're in nitrogen fields. So the majority of the gas, raw gas coming out of the ground is nitrogen. Our offset wells in the Macaulay field that's going into production are 96.45% nitrogen and 3.511% helium with trace CO2. Well, it just doesn't get better than that, because as the raw gas comes out of the ground, it's got to be dried in a naming unit, and the CO2 at 0.0201% just drops out with the moisture. Now you take the nitrogen and separate that element out through pressure and temperature swings and some membrane technology applications, and it can safely be vented into the atmosphere, because 78% of what you are currently breathing is nitrogen. And finally, you've isolated the helium, and now can go through the purification process to take it to a specific grade. And the way they grade helium is like 4.9 helium is 99.99% pure helium. 695 helium, which is more what a chip manufacturer would want, is 99.99995% pure. And you get more money for the 695 gas than you do for the 49 gas, which is more lifting gas. All the lifting gas is 49 helium mixed with 20% filtered air out of the environment, and you've got lifting gas. So, but the generation of the helium is a result of degradation of uranium-238 in association with cesium-55, thorium, and lithium deep in the Earth's crust. And as it's generated and it moves through the crust, unless it finds a trap, it's going to escape back into the atmosphere and it's gone. That's why it's so rare on planet Earth. Unfortunately for us, we found these dome-like structures where we're drilling into a structural high of an anticline through anhydrite layers, which have more density than the windshield in your car. And if they're intact, they trap the helium, and we simply tap into that trap.
Right. And that has something to do, I understand, with helium's absence from shale gas wells, no? That it's able to escape through the small gaps. Is that correct?
Yeah, it'll escape through any known containment. It's very difficult to transport. It'll only stay liquefied for 45 days, and it'll find some way to vent off. The federal helium reservoir or reserve was down in Amarillo, Texas. And on a hot summer day, shipping it from Texas to Phoenix, you'd lose 15 to 18% of your helium in transportation. So it's very, one of the traditional uses is leak detection. If you pressurize a system with helium and you don't experience a drop in pressure, it'll contain any other gas.
And to take a step back again, just to get the context into perspective, if you type helium market into Google, I think this year you would find a lot of articles have been written about a crisis in its supply, linked with the war in the Ukraine, but also to other factors. So could you talk us through what is weighing on the global supply of helium right now?
I think there's actually three critical points to what's created the shortage of helium. Number one, the flood of shale gas hitting the market over the last 20 years has really resulted in no development money going into traditional natural gas fields. And therefore, there's basically been no bid on natural gas for 20 years. Recently, with the Russian crisis, natural gas prices have gone up. But now what you're dealing with is the environmental policies, specifically, I'm just going to specifically talk to North America, but both administrations in Canada and the US are incredibly hostile to hydrocarbons. So let's say you do take a traditional field and go into development on it. How do you get the permits for the pipeline? Because the volumes of gas you're dealing with require a pipeline to send the gas to a collection center, and then the gas has to be processed. All that stuff needs to be going through permits. Good luck. Secondary to that, the BLM, Bureau of Land Management, is under the federal government auspices, and they were instructed back about 5 years ago to auction off the federal helium reserve in the US. It was decided that the federal government would get out of the helium business and they'd auction that reserve off. And at the same time, in August, they auctioned off the large processing facility that they used for purifying the gas. It was a 70-year-old facility anyways, and it was having a lot of maintenance issues. So now you've done away with two sources of helium. One, the natural gas fields in decline. The other one, the Federal Reserve auctioned off, and about 30% of it actually escaped without them knowing about it. So there was only 70% of the gas they anticipated having. And finally, Gazprom in Russia had been spending probably a decade building the Amur complex. It's a large natural gas facility. And when they turned it on in February, it caught fire and blew up. That was supposed to supply 25% of global need. And it just, now with the Russian crisis, how are they going to get the components and rebuild it? So yeah, we're facing a shortage that's to the point where the specialty gas suppliers have declared force majeure on the end users. So even though you have a five-year contract for delivery of X amount of helium, you're lucky to be getting 60% of it. And they're now shutting down MRIs. Harvard shut down 2 of its cryogenic units for research. There's examples of that all over the globe now.
Wow. Okay. Let's talk specifically about Desert Mountain Energy then. According to your company's website, you have over 85,000 acres of mineral leases in the Holbrook Basin in northeast Arizona, and you've so far drilled 5 wildcat helium wells and 3 offset wells. But how close are you to getting helium to market?
If you go to the website, you'll see a photo gallery there under the helium tab, and just hit the helium processing facility tab, and there's a photo gallery. Right now, our processing facility is being tested in Houston, Texas. It was constructed by a company called Genron under contract, and the design of the facility is unique. For one thing, it'll be the only solar-powered processing facility in the world. And the reason we've done that is we're in the middle of the desert at 5,300 feet above sea level and 18 miles off the power grid. So we're putting in 6 acres or 8 acres of solar panels, and the solar panels will be backed up by hydrogen that we found in our helium fields, which is a whole different issue. I don't even want to go there right now because it confuses people. But to start the plant up, we'll be using natural gas till we get the battery packs for the solar. We expect we'll be commissioning the plant probably first, second week of January. The plant itself is built in 4 40-foot C-cans or modular housing units, whatever you want to call them. So once the testing is done in the Genron facility, those modular C-cans will be loaded onto 18-wheel lorries, and they'll move that equipment to the Macaulay helium field, and they'll be set on a gravel foundation that's already been prepared and hooked up mechanically and electrically, and we'll be producing helium. The wells 4, 5, 6, and 7 in the Macaulay field have all had flow lines run from the wellhead to the processing facility. All the road work's been done. The 10.6 acre facility itself has been secured with a 6-foot fence with razor wire. We're just about ready to go into production as a vertically integrated primary producer of helium. And we'll be probably the only company of its like in North America actually doing what we're going to be doing at the first of the year.
Okay. So you're expecting, just to clarify, to start selling to customers by February next year. Is that what I understood from what you just said?
Well, when we commission it and start it up, we've designed the plant to be very flexible because we're going to be very careful how we bring our wells online. So the facility is designed for a minimum throughput of 500,000 cubic feet a day to a maximum of 10.5. Having a low throughput minimum allows us to bring on, depends if Gunner Dome comes in or not, but right now we've got 5 wells for sure going online. Wells 4, 5, 6, 7, and a pay zone in 2. The only flow rates we've published were wells 1 and 2, and they were calculated. So well number 2 has a flow rate of 1.25 million cubic feet a day. If I started up at 10%, I get 125,000 cubic feet a day out of that well. If I can add it to 4 other wells doing 125,000 cubic feet a day, I've got over my 500,000 cubic feet a day minimum threshold. And I can start the facility up. And the day we start the facility up, we will be producing helium out the back end, probably balloon grade to start with, but we will be producing and selling small quantities, and then we'll bring the flow rates on the wells up. As we monitor the health of the wells, it's critical not to start the wells up too quickly and cause damage to the well. And if we do this properly, we expect to get 15 to 20 years of well life out of our production. If we did it in the wrong manner, we'd flood it out and destroy the wells.
Right. So you said you're expecting to be producing 500,000 cubic feet a day.
No. I said throughput of raw gas at about 3% would be, our minimum startup. So if you want to play with numbers, let's say we get it up to 3 million cubic feet a day, about 30% of capacity. And my helium grades are over 3%. So let's just use 3% as a number. That's 90 MCF of helium a day that would come out of there with 3 million cubic feet of throughput. Yep.
At what price then per 1,000 cubic feet do you expect to be able to sell the helium?
Okay, there's something defined as crude helium, and then there's finished helium. Now, the offtakes that the natural gas suppliers sign with the specialty gas producers, or specialty gas processors is a better way to put it. Crude helium is defined as 90 to 95% pure helium. So even if you're Chevron with a natural gas field, in order to sell helium to one of the big 3, you got to take it to 90 to 95%. And last year, you would have got about 300 MCF. This year, we figure you're going to get about 500 MCF. And when you take that gas from the crude form and you upgrade it to 695, you're going to get more like 2,000. So the middleman makes a margin buying it at 500, not taking any risk. They're not drilling wells, they're not exploring, they're not producing. They're taking already semi-processed helium at 90 to 95%, and they're putting it through a processing facility similar to ours and coming out with 695 gas and selling it for like $2,000. That $1,500 bump is their incredibly large margin, which we're going to benefit our shareholders by taking our raw gas and doing it all the way through. Our margins will run 90 to 93% because we've cut the middleman out.
Right.
But the numbers are very opaque. It is basically a helium cartel where there's NDAs signed by the natural gas producers on the one side, and there's non-disclosures signed by the end users on the other side. So neither of those parties are allowed to disclose either what they're getting paid or what they're paying for it. And, you know, the middleman will not only sell them helium, but in regards to hospitals, if you're desperate for helium, well, they're going to force you to buy your oxygen and any other specialty gases that you require, or they won't sell you the helium. They really are holding the market hostage right now.
And can I ask you to tell us a bit more about what Desert Mountain Energy's plans are for 2023? I mean, how many new wells are expected to be drilled, or is that unknown at this point?
That's unknown. We have to deal with the permitting process in Arizona. So we have both private leases, the Macaulay Field's on private land, and we have state leases. So the Rolfing Field and Meteor Crater and Gunner Dome are on state land. The drilling permit process on private land is more like 4 to 6 weeks. On state land, it's more like 6 to 8 months. So right now we've had to reapply to re-enter well number 3 because it was in the courts, and by the time we got the well back, the permits had elapsed. Now we got to go through a process to re-permit the completion and sampling. We've got targets out there and we've applied for permits. It's going to depend how many permits come in, how quickly they come in. So I really can't give you a number how many we're going to drill this year. We do plan to ultimately drill 60 to 70 and have probably 4 to 5 of these processing facilities scattered throughout the Holbrook Basin.
Okay. And since 2020, if the numbers I've seen are correct, Desert Mountain Energy has carried out 2 financings, raising $35 million and issuing 20 million shares. Should shareholders expect to be diluted again to support the drilling of those 70 or so wells that remain?
Our financing needs are completely tied to our helium production. If we end up with more delays due to testing or due to the inability to get the system up and operating because of contractor delays, there's all kinds of delays in this world right now. That facility was supposed to be delivered in July, and here we are in November testing it. We may have to go back to market and do something small. It would be, under $10 million. And with the current price, you'd be looking 3 million units at $3 would give you 9 million. That would be sufficient. We're very dilutive sensitive. Rob owns 4.8 million shares, and I don't own any near what he does, but we're both very sensitive share structure. We're looking at other helium deals out there who have just bloated their share structures out of control. When you take into account that, we've issued 20 million shares since October of 2020. We inherited a company with 55 million shares, all issued under 35 cents. The least we've issued stock for is $1.60 to a high of $2.60. And we've only got an overhang of less than 2.3 million warrants right now, priced at $3.50. So we've been very fortunate in having a good market cap. Trading as high as $4.95. Right now, the share price at $3 compared to what it was like at $4.95 last year is a steal. Like, the amount of development work that's happened in 2022 is amazing compared to 2021.
Yeah, I wanted to ask about the share price actually, because it's been very volatile this year, with a 52-week low of 1.65 Canadian dollars and a 52-week high of 4.5 Canadian dollars. Right now, as you said, trading around 3 Canadian dollars. Do you feel like the price, that what we've seen happen to its price, its slide since its peak in August, do you think that that's attributable to events happening within the company, or is it more a reflection of the macroeconomic picture? How do you interpret that downward slide?
I'll go back to 2021 to start with. Like, we drilled wells 1, 2, and 3 in 2020, and the stock was trading around $2. Then, on no news, the stock moved all the way up to $4.95. And the one well that we drilled in September and announced results of in September of 2021 took $250 million off my market cap in one day. We ate 2.5 million shares into the bid in 2 hours with a successful wildcat announcement on well number 4, which identified the McCauley field as being the one that we were going to put into production because of the raw gas composition. I can't stress the raw gas composition enough for what it does for our ability to be a primary helium producer. Now, the market didn't understand what we'd achieved with well number 4. Number 1, it identified the McCauley field. It also really gave us a lot of knowledge on what we had to have for equipment to drill through that salt basin. We now have a top drive rig with a 16,000 foot depth capability, not because we go to 16,000 feet, we only go to 4,500, but because salt wants to dissolve on you to be able to pull tools out of the hole. We learned we had to have redundancies on all the equipment on the drill site. If a generator compressor goes down, if you don't have the replacement there, you're tied up for another 3 days. The list of what we learned went on and on. It was an incredibly valuable hole. And when we drilled in January of this year, we drilled, the 3 offset wells in 2 months. They brought the average grade of the field up, with 3.511 helium results, and they were all done in 10 days to 14 days on time, on budget. So that was critical to our success moving forward. And, if we're going to bring on 60 to 70 wells, we'll probably drill at least 85 or 90, because we haven't missed yet, but we will miss. And having the knowledge on how to drill in this environment and what equipment's needed not only saves you time and money, but it really contributes to the success of the program.
You spoke a little bit about contractor delays, and in online forums of Desert Mountain Energy shareholders, and there are actually online forums dedicated specifically to people who are owning shares. There are a lot of complaints about Genron and the delays that they inflicted on the McCauley helium processing plant, and they want to know, are they going to be commissioned to deliver the second plant in spite of those delays with the first one?
We haven't decided yet.
Okay.
We're going to take a look around. I mean, they'll be in the mix. The contracts will probably be different in nature than what they were originally. From our standpoint as management, right now we're held hostage by Genron. This is our first facility, and the delays impacted our ability to start to produce revenues in a timely manner, the way that we had anticipated going back a year and a half ago. But now they've successfully built the plant for us. We can't say, well, we're not using Genron because of delays. They've acquired a whole whack of knowledge building our facility for us. that should make it easier next time around for everybody involved. They also had to deal with delays from vendors that supplying valves or electrical components. There's a lot to this. I don't know anybody that's doing a house renovation that's not experienced delays in inflation. We're building a $10.5 million helium processing facility, one of a kind, run on solar. None of the technology's new. The technology's all proven technology. What's new is it's reduced power consumption to allow us to use solar panels to run the facility.
Okay.
And that'll stabilize our power costs too, right?
And do you have any forecast of what gross revenues you're expecting, sort of 3, 6 to 12 months out from beginning production at the first plant, and the same question for the second plant? Or is it possible to put any sort of estimate on that at this point?
Can't possibly do it until I know the flow rates of my wells, and that'll give me the throughput of the plant. And if I know the throughput of the plant, then we can calculate revenues based on what we're being paid by end users for our product. But until I have the volumes, so all I've done for numbers with everybody is saying, if we can produce 3 million cubic feet a day at 3% helium, that's 90 MCF of helium a day. And then you can calculate what we're going to get, less our royalties, taxes, and maintenance costs, which run about 31.5% on the crude helium price. So
Wow.
If I'm doing 90 MCF of helium a day, and I'm going to give you a price of $500 on it, 45,000 is your gross, and I'm going to net less the 31.5% taxes, royalties, and maintenance, $30,825. And you write that number down and put it on the left side, and then you take the $1,500 bump. If I'm going to take it to 695 gas and I get 2,000 in MCF for it, my processing and handling costs are only $20. That's $1,800 on 90 MCF of helium. The rest of that's pretty much straight profit to me. So I've got $30,825 that's had all taxes, royalties, maintenance paid on it. And I'm going to add another $133,000 to it by that bump on the other 90 MCF of helium, purifying it. And I end up making, about $160,000 a day. But I need to achieve that throughput, and I need to have that gas grade, and I need to get those prices to achieve that number. Right. But if you ran it for 300 days a year, it's $50 million.
And would you say that those assumptions that you just stated about the throughput are conservative, or are they maybe on the generous side?
At the start, you said that there was a lot of forward-looking statements and take everything with pale salt. I made those numbers up other than the design specifications of the plant. And because the helium market's so opaque, nobody's really going to be able to go out there and find out what our end users will end up paying for us. We'll have to negotiate that. And the helium is sold on a spot price basis. Now, we do have a supply number and a same-day payment number with the U.S. federal government. So we're running the same program with all the end users. You bring your tube truck in, we'll load it up with the gas you've specified on order. And when the money enters our bank account, we'll open the gate and let your truck out. And we're going to do it on a spot price basis, because we're not going to get ourselves cornered into contracts, especially before we know how much helium we can produce.
And we've spoken a lot about helium, but I understand that you've also discovered hydrogen in a number of these wells that you've drilled. And is it possible to sell this hydrogen? I heard at some point there was talk about using the hydrogen in order to power operations. So if you were going to sell it, do you have any idea about in what year you would expect to start seeing revenues from that?
No, it's strictly a research project for us right now. We're helium experts. We have signed a joint operating agreement with a company out of France called Beam Earth. They're private. and they're experts in the field of commercializing hydrogen. So we'll probably drill 3 shallow wells early in the new year. We've applied for greater density into the Macaulay helium field. So, on 40-acre spacings, if we can drill 3 shallow wells and start to produce hydrogen out of there, we can take a look at actually manufacturing ammonia, which is an easy way to ship hydrogen. You can either use it for fertilizer or easily break it back down into a pure hydrogen form. It's NH3 is the formula for it. And the hydrogen in our fields, we can burn for free if we need backup. So we've got 2 big cat generators that are going to be powered with natural gas. And, if backup's needed for the solar, you've got free hydrogen you can burn. So it does make the plant, once it's up and operating the way we've designed it, would be a 0 carbon footprint.
Another development that shareholders are very anxious about is Desert Mountain Energy's possible listing on the NASDAQ. Are there any updates on that?
No, we don't have the share price to get us there in the first place. And secondary to that, even though we did last year, neither Rob nor myself would want to see us uplist until we had revenue to support the share price. I think it's a huge mistake just to go to a senior listing because you've got a share price that qualifies you. Once you're there, you really are in a shark tank, and the big boys with big bucks can attack your price unless you got revenue to support it with. And I don't know if NASDAQ would be our choice. The more we've talked about it, the more it looks like Amex or the New York Exchange. So Rob's actually in New York next week for some meetings, and he'll be down to the floor of the exchange, and we'll see how everything goes.
Okay, very interesting. And just one final question. In a previous interview, you said that your 5-year plan for Desert Mountain Energy was to build processing facilities globally and to become one of the largest helium producers in the world. However, that contrasts with a statement that I found in the Phoenix New Times, in which your CEO and executive chairman, Robert Rolfing, was quoted as having said, "My goal is to keep it all right here. I want to help the industry here in Arizona." So has the company's view changed since that article was published in March 2022? Or is there some kind of disagreement between the two of you about the future plans for Desert Mountain Energy?
Rob renews his 5-year plan the first of every month. So what he said in March doesn't necessarily indicate what we believe we're going to become in November. Our joint operating agreement with Beam Earth, for example, they're working with Petrobras down in Brazil on some hydrogen prospects. And if they find helium down there, they'll bring us in as the helium experts. So suddenly we'd be in Brazil. We've also had discussions out of state. One of the interesting things that I think the oil and gas business is now starting to recognize is when they drill a hole, they drill to a target. And unlike us, they don't have mass spectrometers at its surface looking at all the elements that they're drilling through on their way to target. And we believe that they've missed a lot of potential nitrogen helium pay zones, maybe hydrogen fields that we've encountered. What we're doing, I guess, is best called as thinking outside the box, which would really describe Rob as a person. He thinks outside the box constantly. That's why he's been able to find this unique geological setting. And we've got a team now. So Rob can rely on the team. He's becoming more of a teacher. He's educating the team and sharing all that knowledge that he's got with all these people. And we're encouraging our team to think outside the box and expand their knowledge bases and think about things differently. Nitrogen and helium do not move like hydrocarbons. you're dealing with very small molecules, and the 51101 rules that regulate the oil and gas exchange in Canada do not work for the environment that we're in. And we've actually been given an exemption by the commissions up here because they've recognized that. And now they're starting to take a look at how do we regulate the helium industry overall when we hit these different types of environmental parameters. The physics are different. Everything about it's different.
Okay, Don, thank you so much for your time. You've been very generous, and it's fascinating. I can't say I understood absolutely everything, but it's been quite an insight. Is there anything that I didn't ask you about that you would like to share?
I think we've pretty much covered everything.
All right.
You know, the biggest thing is Rob's does have a 5-year plan. We're going to continue to build and expand, and you know, the only factor that'll really rein us back in is how fast we get to revenue and how much money we can generate, because we're definitely going to be committing our revenues to expanding our business and looking to building something quite big.
Exciting times. Thank you very much, Don, and cheers.
Okay, thank you.